Welcome. Today I'm going to continue to work on my toy linker project, and today we're actually going to work on the linker itself as opposed to the PDB generation that we have been working on for like the last 10 videos. And what I want to do today is get rid of this hack.c file that is currently needed to build the one bigger project I have been testing on, which is this broke CE game. And what is this hack.c file? Well, it is simply a bunch of DLL imports and a bunch of wrapper functions which wrap these DLL imports. And these functions are then, well, why does this have to exist, I guess I should say, is because these functions itself in the header files are not declared DLL import. And so when the game is trying to use these functions, they are not declared DLL import, which means when I look them up the way I currently look them up, which is wrong, I try to look them up in the import library, and well, they're not there, they are not imports, they're not declared import. But this is supposed to work. I can show you in a sec. But then maybe also how this hack works is maybe interesting. So I have underscore versions of all of these functions that I'm using. And then in buildcl.bat, which is what I'm currently using to compile, because I'm only building a linker, not a compiler here. I have this hack whatever, which just says define these symbols while compiling to be the underscore versions. And this actually also currently causes a problem because I also built the hack file with these defines, which is a little bit weird. So actually if I run this, it also crashes. So if I run A under like remedy, we can see it crashes somewhere in POW, being a couple of layers deep, because it just calls itself again recursively infinitely. So yeah, not great. Anyway, that's beside the point. I don't want to fix this by fixing the hack. I want to fix this by, removing the hack. Okay. And so essentially the issue is, if we make a test program, that if there's an import, let's say some random function, what's a good random function that we could use? Something maybe get standard handle. As a perfectly fine function, does pretty much nothing. Okay. If I declare it exactly as they want me to declare it here, this is not declared spec DLL import, which means I don't think I'm going to be able to link this once I compile it. So let's say cl/c test.c, just a warning, all right. And so if I now use link my linker and try to compile test.obj, then it says get standard handle was used but never defined. And well, we haven't given it kernel 32, but I don't think it will matter. Yeah. And if I use link instead and do some of the arguments which are equivalent to my linker, so no default lib entry main, something like that, we can see it compiles it just fine. And the way this essentially works is that these import libraries contain both the import symbols, but also like wrapper symbols and wrapper compilation units, I guess. And these compilation units I have to link to. And let's see if we can actually observe this in the resulting executable. We didn't compile with debug information. So let's do that one quickly. Let's say C7, so full debug information while compiling, and then while linking debug. And then I want to say dump in a.exe all. Maybe this is already what I want. Not really. Actually, what do I want? I want to well, anyway, let's move on. In the linker, what happens? Why does this happen? Well, when we are passing import libraries, so AR lookup symbol or AR pass AR, something here. We are sort of iterating all of these different files. Essentially, how these work is that an import library or lib file is just a collection of object files, and then later on here I sort of exclude manually every import that doesn't start with dash dash imp dash, every symbol that doesn't start with this dash dash imp dash. So I only want the import symbols. But I think we have to remove this and actually use all of them. And then they're either import symbols, in which case down here they would look like this. So ensure it's an import header, so they have signature of 0 OXFFF. Or they are just object files. And then we have to take the object file and add it to the link when we find the symbol. Okay. So I'm not 100% sure what the best way is to approach this right now, but maybe we will start by allowing all symbols here. And so we have the import symbol string table, which we are building up here. So if I just remove this import symbol base and remove this, this should give us all of the symbols in the import string table, which would seem to be step 1. And then we remove the import symbol base completely. And here we are adding the import symbol base when we are looking the symbol up, and we just remove that. So now we are always looking up over all symbols. And this should still work because it's just a binary search that we're currently doing. So just will be a longer binary search. But let's make sure that's true. Not test, but test.bat. That still gives the same. And if we go into broke, we should also be able to link.bat. But we are not. Requery value exa is not contained in any of the import libraries. So what did I mess up? Oh, there's also an amount of import symbols. But that should be all of them now. Right? Anyway, I feel like we can also remove that. Amount of import symbols. Should now be import symbol string table. Should be amount of symbols now. This should just be symbol string table. Import symbol string table, symbol string table. And amount of strings is unequal to amount of symbols 0. So we know that there are exactly the amount of strings as there are symbols. So that's fine. We have checked that. Oh, we are removing the imp here still. So that was the problem. Don't want to do that. Which means also it's not going to work anymore. Because we now need to look up, when we're looking up the symbol, we're going to have to look it up by the full name. So anywhere we do imp, right here, we have the C string symbol name, just the symbol name data, plus the size of imp, whatever. And are we only using this to look it up? Yes, so we can simply remove this stuff. And I guess we don't have to extract it. And this should hopefully work. Import symbol string table is now the symbol string table. Amount of import symbols is now amount of symbols. Import symbol string table is symbol string table. Import symbol string. And we're through. Are we working now? All right. We are back to working. And well, it will not run because it didn't run before. Maybe if that's not too hard, let's fix that. So we can test. So in build CL, we have to fix that this hack is actually also using the defines. And the way to do that is, I think, to just compile it separately. /c hack.c. Sure. You also get this. Why not? Also get this. And then this is build broke, which is these, and build curses, which are these. Neither of them are interesting for this, and pre-main is also not interesting for this. And then ram link. Oh, we're also linking it here. But yeah, that should still work. build cl.bat. This should now build the hack.obj separately. Now we can do link.bat, and hopefully now it should work again. I'm not too confident, but okay, yeah, it's not going to work in here. That is very true. It did not work, but we have a stack trace. That's somewhat better, I think. Not really sure how to debug it if it complains about that. Maybe like this, step into it, resize the terminal, go. Then we crash at a essentially random location for me. In a switch. This doesn't make much sense, does it? Like this value seems very big. So maybe that's my fault, but I think, who cares for now? Let's just power through. It doesn't, we can't test with it, it's fine. We will just get rid of this hack for now. Okay, so let's continue. We have eliminated that part. Now we should be able to look up any symbol, not just symbols which are import symbols. And well, the next step is to look up all the symbols. So instead of saying here that the name has to be bigger than that, and also start with dash dash imp dash, I'm going to get rid of this if. Just try to look up the symbol. Let's keep the braces just to see. Okay, so we have a name. If it's size 8, that means we have to 0 terminate it. Then, yes, we use the AR lookup symbol. And AR lookup symbol right now returns like a DLL thing. And I think the way I want to switch this is to move that part outside and just return whatever file is associated to the symbol. So the way this works right now is you get an identifier, binary searches the string table we just had, and then from that it gets an offset, and then you just have an AR file header associated to that offset, and after the AR file header there is either the obj file, so the object file, or the import header. And we have this import header, which we currently assume that we get. But instead here, I kind of want to return like a file. Do I just have file? Is this in linker? Yes. So I do just have file. So let's return a file, which as data has file or memory, as memory has file data, and as size has the file size. And then all of this gunk. It's for now. Where were we? Move to here somewhere. And then the way AR lookup symbol works, it is returns a file. Then everywhere where it returns 0, instead I'm just going to say struct file 0 file, and we're just going to make everyone check whether or not the memory pointer is 0 for failure. Okay. Now, this is also going to have to change because of it. This stuff moves down here, and here we get a file, what we're going to call it. It's like the associated file, maybe. Symbol file. File for symbol. Object file. New object file. Symbol object file. Sure, that one sounds okay. And we are assigning then from AR lookup symbol the symbol object file, and if this has memory, we have found it. And then if we have not found it ever, we are printing this error, which is at the very end here. And continuing. Continue. Okay. So otherwise we now have a file. What do we know about the file size so far? We know jack shit. We know it's not -1, I think, is what we know. Okay, but we know AR file header. So the AR file header we already passed, which is, I think, this thing. Yeah, I don't care about that. And we know that the file data is at least file size long because we used stream read range by pointer. For now, let's say add cleanup length checks. And do what we did before, because apparently we didn't check any lengths. So we get the AR import header, which I think the way this works is that this sort of has the same layout as a object file header. Or at least the first two fields are sort of the same. Machine and number of sections. So we assume if the machine is 0 and number of sections is OXFFF, that it's one of these import symbols. So U16 signature 1 is U16 star file data, and signature 2 is this +2. Then if signature 1 is 0 and signature 2, so essentially this, is OXFFF. What's the name type? Oh, that's for ordinates. Yeah, sure. Then if the signatures are 0 and OXFFF, that means we have an import header. Otherwise, this is an object file. And the object file case will be what's new and what's sort of interesting. But for now, let's do the import header case. I'm not sure what to do about this name type. Just assert it or like print something. If it's not mine, if it's not one. Sure, let's say if it's not 1, print error. I think that means it's code, wait, type, name type. Name type ordinal, name, no prefix, undecorated. Symbol send s. I think we have it as a 0 terminated string. Yes. Indicates has invalid import, has unsupported import name type. So whatever, I don't think anyone's gonna use this and run into it, so who cares? Symbol name data. And this is not file data anymore, this is symbol object file dot memory. File size is smaller than, oh, this was the length check. I see. The other way this worked had the advantage of just being able to report bad errors and bail out. Okay, if the file, so file size is symbol object file. Let's maybe just pull these out. U8 file data is symbol object file data and the size. It's the size. That means this should work again. This can be file data again. And here should return 1 now. That import symbol for this. It's maybe a better error message anyway, but whatever. Just don't tell it people what's wrong. Just tell it it's wrong. Okay. Then we get the hint. As from the import header. And let's move all of this up 1 level. We try to find the DLL import node by taking the identifier and the DLL name. Here's another check. I have to say it's a bad import symbol. I should also tell you the file, I guess. Maybe. But maybe for now I also don't care. Yeah, bad import symbol for that. We try to find a DLL import node that already exists. And I think the DLL list just exists here as well. Just have to change arrows from dots. And then we don't return the node. What did I say here? Symbol was used but never defined. Here I say it's not contained in any of the import libraries. That kind of doesn't exist anymore, that concept now. And then here we mark it as a DLL import symbol, symbol size. Name, size of name hint, yeah. This also has to happen here. So then in the object file case, this is what's new and interesting. But because this wasn't supposed to happen before, I think what I'm going to do is just report an error right here and then see that I didn't break anything. And what I have a symbol name. Yeah, that still exists. DLL hint. This is not a parameter of this function anymore. Here are lookup symbol. DLL list we don't need. Means we also don't need arena, I think. File data. File data doesn't exist because it's symbol object file memory. Data. Memory. Import header. DLL list. Undeclared item. Didn't I check that? Oh, DLLs. And this cannot return. That's true. DLL import node DLL. In this case, DLL is it, and we break. Then here, if we don't have a DLL, create a new one and add it to the list. Arena. Okay. It crashes. Does it crash for test? No. Link.bad. Oh, I can give it remedy bg. That's nice. So link.bad remedy g. What's your problem? DLL is 0 because here's node. And that at least did something. Good enough for me. Now, what we should be able to do is remove hack.obj from the link. And now we should get in the add incomplete part. Right. Underscore, okay, yeah. Because these still have underscores. So we have to also remove the other hack in build cl.bat, which is this hack. Okay. Link.bat. Symbol under memmove was used but never defined. But we don't have add incomplete. Interesting. Underscore memmove. Did I hack it up even more? Git status. Do I have git here? No, I didn't clone this. Bear grep underscore mem move in C files. Yeah, might have fixed these up manually as well. There's also an arst file which has an underscore mem move, which is interesting. In WinCon. But I don't think I compiled that, I assume. Maybe I do, maybe I don't. So how to do this properly? So I can just edit all of these, I guess. Pretty sure I did this at some point. Seems like something I would do. I mean, I can check if there is actually a thing as underscore mem move. But I don't think there is. There's underscore big mem move. Apparently. But yeah, I think this is me hacking it up. Beautiful. Number 1. Edit. Number 2. Could not open file. I don't know what how it's trying to open these. That it is not working. Edit. Now, what is this arst file? Mem move, mem set, mem copy, mem comp. I'm not sure if I compile this. Oh, I think that this is from when I was trying to compile this project with my compiler. Pretty sure. So that's probably broken after I do all of this, but that's fine. Cannot find mem move. 79. Uh, 97. Okay. There it is. Okay. We are good, I think, now. If I do this again, we are just in hack and arst. So let's try that again. Build cl.bat. Symbol mem move defined in, these are warnings. Is imported in delge, function v delge. In premain.obj. Warning, symbol mem move defined in premain is imported by, okay, maybe fine. This is just warning me that there's both a DLL import, but also a definition in another file. Symbol under imp memmove was used but never defined. How is this supposed to work then? What? Now I'm a little bit confused. What am I linking to? I'm linking to... I don't think I need full paths anymore, so I could try to get rid of those. User kernel32 ucrt lib. I think I need more than just ucrt lib. If I recall correctly. Is this the one I'm looking for? No. This one maybe? Introducing it? No. I guess maybe these look fine. Is there like a thing to do multi-line bad lines? Okay. Very interesting work right here. But I think it's gonna drive me less insane looking at this. What? Damn, there's a lot of stuff in this shit. Actually, alright, now I'm almost done. I think there might have been like a neat way to do it more with a macro. Right. Then I think I don't need these paths anymore. I think I fixed that. So ucrt lib, kernel32 lib, user 32 lib, whatever this is, however this is pronounced. And let's see that that does the same thing. Failed to load. Okay. I almost guessed that. So what I want to do is replace this with a space and then this. Okay, that looks exactly the same. That's great. And then I wanted these other ones, which are VC runtime and MSVCRT. And these, I don't know, maybe I do need for path for, because these are like compiler specific, maybe. First off, we crash. That's always great. Not a.exe, what am I doing? Link.bat remedy g. In a memcopy from main here, we have a name which, what's the name? Where do we get name from? Where are we? We are currently trying to write out the import directories. Non-import name. That one seems bad. What's the symbol? Cosine. So we have cosine, and it somehow was identified as a DLL import. It's not what I expected to happen. But maybe this is how it works, which would maybe be fine. Way sooner here. I guess all of these might also be DLL imports, marked as DLL imports. This is really not what I expected to happen. Expected to be there to be like a wrapper object file. And I feel like there has to be. So here we are for imp rename. That's fine. There was a stir cut already. Okay. When I just start to get fast. Stir comp. Here we have a stir comp, and it seems to be an import symbol. Is that because we kind of screwed up something up here, or why is that? Or are these actually just import symbols? And my linker has to do some special stuff for import symbols which are not declared DLL import. I would suck. I mean, maybe it would be easier actually. How can I verify this? Does dumpin work on lib files? Do I have a lib file? Let's try to compile like a DLL, I think there's some lib file, but I don't know if that does anything. Maybe that's fine. Dump in broke.lib. What do you tell me? No, this is probably so it works. That's good. Imp these. Public symbols. Okay. It's a library. Sure. Then this is some header no one cares about, I think. And these are the symbols in there. These are sorted symbols, that's probably better. Debug S. iData. So these seem to have object files in them. I guess I should check which thing I'm strcomp, which library file I'm using here, and what's the problem. So let's see that. And then we get rid of this. There were quite a few that weren't like this, and then I'm searching for one that doesn't say imp. Maybe I should have just written code. Ah, there's a stir cut. Okay. And, well, can look at the AR index. 0. Did it work? Yes. The AR index, so AR files at AR index at 0. What am I doing? UCRT lib. Sure, maybe. So I want to look at UCRT lib. Sure. I had the full path just a second ago right here. You come with me, kind sir. And dump in this. Or maybe not the smartest choice, because you, for some reason, can't control C dump in. Let's do it in here. It's way faster in here anyway. Version machine. So these are all, I'm a little bit confused. Yeah, so these seem to be these import headers. What I can say. Stir. What did we have? Do I still have it open? Yes, stir cut. Stir cut. Okay. Sure, let's do it like this then. Let's try to link to stircut and see how my executable looks. I think stircut's just 2 strings or something. Yeah, this looks fine. And let's go into test and do pretty much exactly the same, but use stircut. Okay, /c7 test.c. Sure, gs minus, maybe /c, importantly. And then we want a link with no default lib test.obj, entry being main, and one more thing, brain. We're almost there. UCID, right. That seemed to have just linked. I should have a test. That seems to be okay. We also want to have debug. And then I can look into remedy bg.a.exe. Not A. No. Test. This stircut. Yes, this has associated code in my executable. This associated code. Wait, no. Does it or does it not have associated code in my executable? How does this work? I can't want the instruction. Okay, I'm gonna use dumpin. To disassemble. Cd dot dumpin test.exe disasm. Okay. So none of this is my fault. But okay, here we have this thing. This is what I was thinking about. So it did put some code in my executable, which because this call called stircard, and stircard's here. So I guess we have to implement that. I would have guessed that this worked differently, but I guess it maybe just has some linker magic in it. Okay. Code data const. Does this tell me anything? Or do I literally have to go off the name? I might literally have to go off the name. I guess that's what the compiler produced, so maybe that's fine. So in this case, let's say, yeah, currently not, we are currently not supporting static linking. Needed for this. All right, this means we're doing something different than I thought we would be doing. I thought we would essentially implement static linking. But instead, we have to add, I guess, a hack here to produce the code, I guess. Then when linking to the symbol, how's this going to work then? We thought I have to insert two symbols here. We have to have both this symbol and the imp symbol, and this symbol has to be flagged with like another thing, is DLL import thunk or something. So let's do that in linker. DLL import. Is DLL import. Now I guess have a U32 is DLL import thunk. And a DLL import thunk index maybe. And here, okay, if we are prefixed with the underscore imp, I guess, this is happening. Symbol, name, size is bigger or equal to size of imp -1 and stir comp, I guess memcomp, stern comp of symbol name data dash dash imp dash for the size of this. -1 is 0. Then we do one thing. The symbol is a DLL import. Otherwise, this symbol is a DLL import func. DLL import. Want this variable both here ++ and then also for the symbol. So the thing I'm weirded out by here is that I kind of have to also insert this dash dash imp dash symbol, I guess, implicitly. Because otherwise I don't see how I would link to that afterwards. Maybe I can just do this. And you use the DLL import node. Okay, now this will break a bunch of stuff. I think. Let's call this import thunk count. It's better. Sure, let's just rip it and see what breaks, I guess. Because now these are not prefixed DLL imports anymore. Not declared DLL imports anymore. Right, that just compiled or linked. It's not good. So we have these symbols. They are now marked import thunks. Then when we produce the import directory, I guess, is where we also have to deal with these symbols. Man, this is somewhat annoying. Yeah. Okay. I was trying to power through it, but I think I have to think on how to structure this. Because now we have to somehow generate code for these. There are somehow DLL imports, but not always, because sometimes we could both import them in one module, but also import them without the --imp dash in another module. And it just gets really messy. So I think, actually let's just do it, fuck it. Shouldn't be that hard, should it? Let's for now suppose that these are, so the DLL nodes just have a name pretty much. And then the symbol, how do we do the, why is it jumping to there? Come on. In the linker, we want DLL import, where we write this thing. I think because we want to essentially also do this and just say, for now, we don't support importing both by and without. Just going to be wrong, and that's fine. Okay, calculate the DLL import size. I don't think we care about the imports here. Calculate debug information size. Want to go here. And here, the way this works is that we go over all external symbols, right? And we say if it's not a DLL import, continue. So I'm just gonna also mark these DLL imports, I think. Or I could mark them. Yeah, let's also mark them DLL imports, sure, why not? Actually, no, let's not. So I'm going to say if it's a DLL import, it's not a DLL import, and it's also not is DLL import func, then we continue. Then we have the non-import name, which starts out at the symbol name. And if it is not if it is not a DLL import func, then we say non-import name is string this, and we strip the imp. I guess we could do this easier like this. So plus equals the size for the imp, and then minus equals from the size. And what am I missing up? This. Okay. So far so good. Now I kind of want to find the text section where we do this stuff. So first off, when we link the thing, it's now not marked as DLL import. So if it's defined, we go somewhere. If it's DLL import, we go somewhere. If it's image base, we do this. And otherwise, we assume it's BSS. But now we also have the case where it is a DLL import thunk. And then the symbol relative virtual address is the DLL import thunk base plus 8 times the found DLL import thunk index. Then we need to allocate all of these thunks and write encode for them. I do similar stuff here where I try to find like a certain section. Like here somewhere. Here I've tried to find the RData section, and if I couldn't find it, I allocate it. And so I think I want to do the same thing with the text section. So if we have import thunks, then first of all, let's make a comment. Allocate a text section if it does not already exist. And we need space for the DLL import thunks. Then you come with me, you come with me. Beautifully. BSS. Let's try that again. BSS text. Five, 6, 7, 8. What are the usual characteristics of a text section? Dump bin / headers test.exe. And what we want to allocate is this base. So in the linker, we have this count, but then we also have the symbol thunk index. And so we want the DLL import thunk base. Which I guess is a U32. Starts out at 0. Then the thunk base is text size. I think this should work differently. Doesn't the other version of this work differently? Oh, this is here where you can't see it. Great. Linker 1308. Like, I feel like I just want this. Amount of image sections, sure. Size of raw data can start out at 0. That's also fine. And then the name, we set in the characteristics. I feel like that's all I need. So, we have the thank base now. I guess we don't have the relative virtual address of that yet, of the text section. So would be text section relative virtual address plus DL import thank base plus this. Okay. And the text section should be like this. Image text section header. Okay. Now for all of the things. Sure. Not for all of the things, for all of the things in the image, all of the external symbols, because we don't know like I want this loop essentially again. So for all of the import things, we can get the name. Maybe that helps us. Let's look at the code it produced. Where are we? Neither of them is what I want. So go away. Remedy.dbg a test.exe. Here, test is jump, quad word. We have it. Is remedy able to tell me the bytes? Show code bytes. Yeah. Right, the bytes don't do that much. Well, I guess they do. Right. So this is the offset from RIP, and these are the bytes that are before it. And so we have 6 bytes per thunk. And so this size of raw data is plus equals 6 times the thunk count, which is DLL import thunk count, I think. Count. Yeah. So we can first write in the data. So the address is I guess we don't have that yet. So for now we can only allocate the bytes. Then once we've allocated the bytes, we right here allocate all of the virtual addresses. And we have the image base. Go over all of the sections in the image. We get the image header. We get the relative virtual address where we currently are. We match the size of raw data. Then we've already allocated the header, and afterwards we allocate the rest here. So we allocate the image physical size minus the header size. So after this point, the physical size of the header is allocated. Then we do some calculations here that don't matter. And then here we write in the DLL import information. So here I also want to have do exactly what we try to do here. So write in the DLL import func table. Then the destination is the image. What was it? Image text section header, which should be set if there are thunks. We have the text section header. That gives us a offset in file or something. And we also allocate it in this loop right here. The pointer to raw data. And we add that to, I think called the image base. Maybe. Yeah, image base. Pretty much exactly what this does. So we get the image base plus the text section pointer to raw data plus the func no func count func base. So this is the func table base. Then we have the func table base plus plus 6 times the size of one of these funcs So plus the thunk index, so symbol don't know why this one is so hard for me to remember. I think these were the 2 bytes that were in there, but let's see again. OXFF, OX25 is jump keyword pointer rip plus, and then afterwards there's an offset. And that's rip relative. So first of all, we need to know the virtual address of this. And the thunk table relative virtual address works sort of the same. It is the image text section relative virtual address plus the DLL import thunk base. Yeah, this is also how this works. And so we have the thunk table base plus 6 minus, actually where we want to go, minus the thunk table relative virtual address plus 6. Because the rip always works after the instruction. So after the 6 bytes, that is where rip currently is when the instruction is executing. And then we have to subtract that one to get us to 0, and then plus where we want to go. So, which is this question mark, question mark, question mark. And we want to go to the import address table, I think. This is sort of where what usually the relocations do. So let's look at the relocation for a DLL import. And for a DLL import, we have the symbol relative virtual address is found, DLL import relative virtual address plus found 8 times found this index. I think this one should already be set. Right, we set it just above when we fill in the DLL imports. And so let's do U32 rip RVA is this, U32 dest RVA is the import address table relative virtual address plus 8 times the import index. And found in this case is symbol. And then we have the offset is the dest RVA minus rip RVA. And this should hopefully produce the correct code. Is there anything else to do? I don't think so anymore. Oh yeah, this is not relative virtual address, but just virtual address for whatever reason. Okay, and so I'm going to link the easier file first. So linker test obj. Doesn't find stircat, so I give it ucrt.lib. Cannot find start. Okay. Isn't there? I think I have searching. Don't I? Maybe I don't. I could swear I have searching. cl/c test.c dash gs minus, and that did do something, but cannot run it. Why not? This stircat doesn't look too great. I think this is just that here. The name from the non-import name for the non-import name size. I think I know. Namely, we didn't allocate space for the name probably. Here we do. Nope, that's not it. Right here, this was it. Symbol size. This stuff also has to happen here. But the symbol size is now just the name size. And we have the, yeah. Then we have a beautiful little stircat in there. And I also want to look at the code. But we now at least have what I expected. So this is the jump that we put in there. And it crashes. So something is off. So this should be the stircat, which should jump to the correct location. That one's okay. But then we are here at this call to rip plus for ff0. Let's see what OX3042 plus 6 plus OX4FF0 is. That's at 8,000, and I don't know if I can see how this is. Like, that's outside of the image, because the image ends at 6,000. So the jump is off. Test RVA. Func table relative virtual address is wrong, but that doesn't matter. It shouldn't be that off anyway. But the RIP RVA is the this is missing. And then the dest is the import address table relative virtual address, which I thought we set before. Yeah, we set it right here. Plus 8 times the symbol DLL import index. That also seems correct. And when we have RIP plus something, we should subtract the RIP and add where we want to go. Also seems correct. Let's look at the symbol. And let's look at the RIP RVA. That one seems wrong. Image text section virtual address. Is that wrong? Not set? No, that one's set. This is a U8. Who decided on that? Stupid bug. We built the linker. Sure, let's wrap it in here. We now see RIP RVA. 1 second spell. That one looks okay. Dest RVA. That one looks okay. I would guess. Old has it. And then once that built, let's see A. Okay. Let's build that with debug information. CL/C7-GS-C test.c. Then link it with my linker. It has a breakpoint in there, but that doesn't matter. This guy. Then a remedy.bg a.exe. We call this guy just down here, which calls somewhere into UCRT base, presumably to stircat. That's good. Okay, so it seems to be working. So let's give it the real test. Can we link broke CE? And I guess maybe running it is still might be a problem, but we'll see. First of all, let's link it. I still didn't remove the fucking breakpoint. Right, not like this. We can link it. That's good, that's good, that's good. So that's success criteria for today. But let's also see if we can run it or if there are more bugs in my linker. There might be more bugs in my linker. Let's see where we are. Calling POW, I assume. With like some values. I just love how well everything works. Like, I don't know why anything here would crash. But it does seem to be this instruction. Which the only thing I'm pausing here and being like, is that this is one of the symbols that what we are currently doing is supposed to be happening for. This is one of the symbols which was imported but not using DLL import. And we are at something that should still be in the executable. So let's do that. Okay. I don't think we are done yet. We have emitted a call here to 14.22.44 8F. And there are a bunch of OXCCs there. So what's going wrong? So first of all, let's see the thunks. Thunk for %s, %.s, add %x, let's say. And this is the symbol, name, data, symbol, name, data. First one was supposed to be size. And then we want the, I guess just grep RVA is fine. Yes, let's subtract the 6. And then we can see for stircat, it's at 22.44.f, 22.44.55. And we were trying to, where's POW? There's POW. 22.44.7f. We were at 44.80. So like 7f. So these were the bytes. That seems to be correct. Where are we writing these OXCCs? Oh, we're just clearing the whole section here. How is the other guy working? This is happening. No, this is happening before. Right? This is the only place we're writing OXCCs. And we're writing it to the entire text section. And then we're writing in the DLL import information. And subsequently, yeah, the DLL import thunks. So we're writing a thunk for POW. One thing I find annoying is that these are unaligned, so let's align them by 2 at least. Very quickly here by just saying text. The text section size of raw data is this +1 and not 2, not 3. That should align them way more pretty. Now, why are they OXCCs? Let's redo the link. Oh, this already redid the link. I'm stupid. So 4490 is POW is 4480. This says it's calling 4490. So is that what's going wrong? Unable to open README. What are you on about? Oh, I have this open. Right, and if I go back hex 10 bytes, that's in range and here. And these look like import thunks. I didn't actually recognize it at first, but this is very much so an import thunk. Which means we are somehow off by OX 10 bytes when we are calculating the relative virtual address this has to jump to. Which is where? That's in the applying relocations, where we figure out the relative virtual addresses. So here is, if it's an DLL import thunk, we take the relative virtual address of the text section, we add the import thunk base, and we add 8 times the DLL import thunk index. Seems correct to me. So we have found, name, size, found, name, data, and we have the symbol relative virtual address. Now we fail doing linking. Invalid arc. That means one of these names is corrupt, I suppose. Watson. F right. Oh, when it's open somewhere else. If not out and fails to open a.exe. It's simply this. Yeah. Okay. And we can say found produces 22, 44, 90. I want the virtual address, I want the base, and I want the index. Yay, send x. What was it? Base. Send x and the index. Now I want to compare that to what similar information gives me in the case above. Where we have also the name, but it's symbol. We have the symbol relative virtual address, which would be rib RVA -6, I presume. Anyway, should be fine. We will see. We have the image text section thing, which we have here, which we use here, I guess, image text section virtual address. We have the base, which should be defined, and then we have symbol func index. And this is func. Symbol. Okay, it finds these a lot, which makes sense. Func. And we were at POW. $22.44.80 versus $22.44.90. The VA is the same, the base is the same, the index is the same. But one is 80 and one is 90. So how are both of them calculated then? We have this versus rib RVA this. I am so stupid. Okay. One of them says 8. One of them says 6. It is 8 times the DLL import index, but it is 6 times the DLL import thunk index. That one cost way too much time. Okay. Almost there. We first have to quit this. We can link again. And do we work? We seem to be working. Okay. That was not in time, I guess. But we can try here. We are still crashing. But we are crashing in the same spot that we crashed before, I think. Before we did any of this fixing. Which, if that's the case, I'm going to call this success. Yeah, in this thing. Which probably means there's some bug here that I still have to track down. But we now got rid of hack.obj. We did a little bit of a different thing than I expected to. I expected to have to implement static linking, but instead we had to implement like stubs, I guess, or thunks. But anyway, it works now. I hope you have enjoyed it, and if you did, maybe see you again.